Hello, my name is Jeff Carroll, and I've chosen to talk about the power plant on the CRJ 200, or more specifically the General Electric CF34 3V1 engine. I drew a basic drawing as best I could of kind of the basic components of the engine. I'll give you a run through of them. So you've got two spools on the engine. Your N1 spool consists of a fan here, which is basically your low pressure compressor that's connected with the shaft here to a 4-stage low pressure turbine at the back of the engine. And then the other shaft that goes around that is the N2 shaft. So I can label these. So the N1 is this portion here, and then the N2 section is a 14-stage high pressure compressor here, and then a 2-stage high pressure turbine. So the N2 spool is the kind of center core of the engine, the hotter part of it, I guess you could say. And then beyond that, you have kind of the cowling, the exterior portion that covers up the outer core of the engine. You've got ducts here for the bypass air, which is blown past by the fan here, and then the core air, which is what actually is burned after it's compressed, comes out this portion here. And then you have, driven by the N2 section, you have a tower shaft that comes down to the accessory gearbox that has a bunch of components on there that we'll talk about later. And then I've just kind of drawn boxes of some of the computer or mechanical control units that are involved in the engine itself. So starting out from the starting portion of the engine, on your accessory gearbox you have an air turbine starter, and that's supplied by one of three sources. It can be the APU bleeder, the cross bleed from the 10th stage compressor, which we'll talk about that later, and an external air cart to start the engine. So starting out, you have to have air and you have to have DC power. So air gets pushed in from whatever source to the starter, which will turn this shaft to the accessory gearbox, and that starts the N2 shaft spinning. So that begins to pull air through here and compress it. And then as that is compressing air and pulling it through it, then that moving air will turn the N1 shaft with the fan as well as the turbine back here. Once it reaches about 20% of the N2 velocity, fuel gets introduced back here in the combustion chamber, which is in between the high pressure compressor and the high pressure turbine. So fuel is sprayed through nozzles in there, and there's two igniters, A and B igniters, that will light that fuel off and accelerate, starts burning, and that continues to spin the shaft even quicker, and in turn spins the other shaft as well with the airflow. And that air, probably should use the red marker, that air that's burning is going through all 6 of these turbines. There's 2 on the N2 and 4 on the N1, and that just is basically self-sustaining as long as there's a fuel supply. So that's what's spinning the engine. So that core air comes out of these ducts here at the back, and that accounts for about 20% of the total thrust of the engine. And while it's spinning the fan, there is a ton of air coming through here, both of these ducts, that is about 80% of the total thrust of the engine. This is a high bypass turbofan engine, so the majority of the air is bypassing the core, depending on the engine, anywhere from 3 to 5 times the amount of air that goes through the core of the jet actually goes through the bypass ducts and produces, the majority of the thrust. So while this is spinning, as we talked about before, this tower shaft on the accessory gearbox, there's a number of items that are driven by that shaft. There's a hydraulic pump that obviously powers the hydraulic systems of the aircraft, whether it's flight controls, landing gear, flaps, that kind of thing, depending on the airplanes. All of them are slightly different. But you have the hydraulic pump off of that gearbox. You have an oil pump, engine-driven oil pump. So that oil pump has a couple of purposes. There's a series of bearings along the shafts that support, actually support the weight of the shaft as it's spinning, and that stuff gets hot. So the oil goes through there to lubricate it, keep it cool, and then it's returned back to a sump or whatever with the pump. So the pump is going through there with all the bearing seals, and then as well as the gearbox itself. It has to lubricate and keep the gearbox cool so the parts don't come apart from heat and friction and all that. Next thing is a fuel pump. So the engine-driven fuel pump is pulling fuel from the wing tanks and providing it to the nozzles in the combustion chamber. Obviously, it needs to get fuel under pressure to itself somehow to continue running, so that's what the engine-driven fuel pump does on the accessory gearbox. You have the air turbine starter, which we talked about earlier, that is where the air actually comes in and starts the N2 shaft spinning off of this tower shaft here. Then the, let's see, you've got a generator, so I think it's a 400 hertz, 30 kVA generator that's driven by the accessory gearbox, and then the engine alternator, which basically tells you the N2 speed, but also goes to the engine control unit, the ECU, which talks to a number of different things. You have all sorts of sensors, speed sensors, temperature sensors, all those sorts of things, oil pressure, whatever, that are all feeding information to the ECU, which is then sending a signal to the fuel control unit to tell the engine what it needs, or how much fuel that it needs for the given situation. And that's tied into the thrust levers, and then the APR, which is the automatic performance reserve, which is a kind of a cool feature. If one of the engines fails, let's say on takeoff while that system is armed, it'll send extra fuel to the engine, giving it about a 2% thrust increase, which works out to about an extra 500 pounds. So total of around 9,200 pounds of thrust with the APR on. Normally it's about 8,700, I think, is the rated thrust on this. So that's kind of a nice feature to have if you were to have an engine failure and need a little extra bump from the thrust. Some other stuff on the engine, the bleed air. So there's 3 sources of bleed air that are pulled off of the high pressure compressor. The 7th stage, which just really means it's just the 7th level of compression from up here, the 10th stage, and then the 14th stage. So the 7th stage air, that just goes down to pressurize the oil seals on the shaft bearings, and I believe just to keep it from cavitating, just keeping constant head pressure on the oil with air. The 10th stage bleed air is used for a lot more things. It's used for starting if you have to cross bleed to the other engine to start if the APU isn't operative, and then it's also used to send air to the packs, provide air conditioning, heating, pressurization for the cabin, and it's also used for avionics cooling for the aircraft. And then the 14th stage is the biggest draw, and it's the most air pressure and most heat, as the air is heated as it compresses stage by stage. So the 14th stage is used for thrust reverser operation to actually move the cowl back for that, and it's also used for engine anti-ice. So the 14th stage bleeder would be tapped off up here to the lip that goes all the way around the air inlet, so it'll melt off any ice or prevent ice from forming in the first place. And then it's also sent out to the wing anti-ice as well, which is a very high draw bleeder item. The other stuff on the engine is really the thrust reversers. So when the aircraft lands and needs a source of power to help it stop, other than the brakes and the spoilers, there's little blocker doors right here that will close, and then the cowl, so these close, and the engine cowl slides back a little bit, and that takes the air and actually forces it back forward, so you have forward thrust at that point to help slow down the aircraft as it's on its landing roll. So that's kind of the basic overlook of a CF34. The components, what it can do, what's on the gearbox, the thrust rate, the thrust percentages for which type of air source, I think that's about it. Thank you for watching.